Hello, class. It is Mr. Sutton. Today we're going to be talking about Math 10 Skill 7, multiplying and dividing polynomials. So there's two methods we're going to talk about when multiplying polynomials. We're going to talk about the box method as well as the distribution method, which you also might have seen called FOIL with the acronym FOIL. So let's take a look at this first example. So we are trying to multiply these two binomials. And these are binomials because they have two terms, right? 1, 2. This is binomial 1, 2. So that's why we call it a binomial. Remember, polynomial just means multiple terms, so that encompasses binomials, which means two terms. So the box method, the way we would want to multiply these with the box method is we want to have one of the binomials go across the top of a box, so 2D, and then we can just say plus 3, and then the other binomial will go across the side, 3D plus 1. Now it's important to note what the signs or operations are. So that's why I did include the plus, but the plus doesn't really change anything. What matters is if we have a negative. So after that, we want to separate our box like this so that the terms align with separate boxes. And then what we want to do is we want to multiply it in such a way so for this box, we want to figure out which terms line up with that, and the 2D lines up with that, and the 3D lines up with that. So those are the things we want to multiply and put in this box. So 2D times 3D would be, so 2 times 3 is 6, and then D times D is D squared. Now in this box over here, lines up with a 3 and lines up with the 3D. So 3 times 3 is 9, and then D, we just put on the side. This box right here lines up with the 2D and lines up with the 1. 1 times 2D is just 2. And then finally this box right here lines up with the 3 and lines up with the 1. 1 times 3 is 3. Let's add 3. So now we have done our multiplication. Now we have all of our terms, so we can just write these out. 6D squared, and these are all positive, right? Plus 9D plus 2D plus 3. And we can combine like terms, the 9D plus the 2D, so we have 6D squared plus 11D plus 3. And that is our final answer. Now we can do the same thing, but with the distribution method. And remember, this is also called FOIL if we're talking about binomials. So if you've heard FOIL before, that's only something we talk about when we're multiplying two binomials like we have here. And the reason that it's called FOIL is because, again, it's an acronym. And what this stands for is first, outer, inner, and last. So it's a way of just organizing your distribution because you want to distribute everything in the first binomial to everything in the second binomial. So first we do first, 2D times 3D, which is 6D squared. And then we do outer. So that means, so the first means we just multiply the two first terms, and then outer means we multiply the two terms on the outside. So 2D is on the outside, 1 is on the outside, So I'm going to multiply the two outside terms. So that'll be plus 2d. 2d times 1 is 2d. And then we do inner, so we multiply the two inside terms. So that's 3 and 3d. So 3 times 3d is 9d. And then finally we do last. So we multiply the two last terms. So that's 3 and 1. 3 times 1 is 3. Now, the reason we have the box method is because this kind of distribution can get very confusing. Notice there's a lot of different lines going on here. That's also why we have this FOIL thing to help you keep your distribution organized. So we have 6d squared plus 2d plus 9d plus 3. Once again, combine like terms, 6d squared plus 11d plus 3. So we got the same answer. This box method, I think, is a better way to organize things, but you also might see this distribution method, or here are the words FOIL, and so I wanted to show both things. Now let's go ahead and look at this next example. And one thing I forgot to mention, I do want you to write down both methods in your notes for these, and I also want you to write down why you might choose one method over the other. So you might choose box method because it's a better way to organize things. This is one where I think distribution method might be a little more straightforward, because notice we have, this is a monomial right here because it's just one term. Multiplied by a trinomial right here. That's 3 terms. So the box method for this one would look like this. We would have 7t and then minus t cubed minus 3. And it's important to keep your minus signs with your terms because you're multiplying by a negative number there. And then on the side of the box, we would just have 3t squared. We only have that one term there. So again, we want to separate it. So a box method like this just seems kind of silly because we just have the one term on the side. But if that is what you feel is the right way to do it, then please feel free. 3t squared times 7t, that would be 21t to the third power. And then 3t squared times a negative t to the third power, that would be negative 3t to the fifth power. And then 3t squared times a negative 3, that would be negative 9t squared. So we want to go ahead and write out these terms. And to have it in standard form, we want it from the highest power to the lowest power. So I would write this negative 3t to the fifth power first, and then plus 21t cubed, and then a minus 9t squared. The distribution method for this one, I think, is a little more intuitive because it's what we're used to with distribution, where we're just distributing one term, or we have a monomial. So we would just distribute like we normally would, just like that. So once again, 3t squared times 7t is 21t to the third power. 3t squared times a negative t cubed would be a negative 3t to the fifth. And then 3t squared times negative 3 is a negative 9t squared. And once again, we want to order this from highest power to lowest power. So we'd say negative 3t to the fifth plus 21t cubed minus 9t squared. So again, make sure you write all of these things down. And for this one, you might want to say that the distribution method is a little more straightforward because we're just distributing a monomial. Now let's take a look at this next example. Here we have a binomial multiplied by a trinomial. So this is one where I would definitely recommend the box method. because if you start distributing this, you can't even really do FOIL with this because we have a binomial and a trinomial. So once you start distributing things, you're going to have to really keep track of how you're organizing that. And I will show you how I do that in a second. But I do want to set up a box method because I think the box method is the better way to go for these. So this is how you would set up the box method. Make sure you have your negatives attached to the terms that they're in front of, because you want to, like when I do a squared times this, I want to make sure it's a squared times negative a, so that I get a negative a to the third power. All right, so I'm going to go ahead and fill out this box. I'm going to pause the video and do that. All right, so this is what I got when I multiplied all of these things. So take a second and check those, make sure that you agree with everything. But then I want to go ahead and write all of these terms out. And that is an important step, and I think a mistake a lot of us make is when we go from here to here is we forget some of the terms and we leave them behind. So what you might want to do is, like when you write down a4, you might want to cross that out. And then when you write down negative a3, you cross that out. When you write down 8a squared, you cross that out. When you write down negative 3a squared, cross it out. When you write down negative 8a, cross it out. And when you write down negative 24, cross it out. That way you know, okay, I wrote all of these down, especially when you get to the larger boxes. You're going to be more prone to accidentally forgetting one of them and not writing it down. But then we do want to combine like terms. Make sure you have it in standard form so you have all of your terms listed from highest power to lowest power, which I already did that, but I can combine these. 8a squared minus 3a squared is 5a squared. And that's the only thing I can combine. So this right here is the final answer. And I do want to show how I would do something like this using the distribution method. Even though I think the box method is way better for something like this, you still might come across a teacher maybe in the future using the distribution method like this, so I don't want you to be totally confused by that. So the way I would organize my distribution, again, you want to make sure you distribute every term from this binomial to every term to this polynomial. So what I do is I just start with one term over here. I take the a squared and I multiply it with everything over here. So I first multiply a squared by a squared, then I take a squared times negative a, then I take a squared times negative 3. So I do that, and then so I'm going to go ahead and write all of those out. So that's what I get for those. And then I move on to the second term over here, and then I multiply that with everything. Right, so 8 times a squared, 8 times negative a, and 8 times negative 3. And maybe you've also heard this called the claw method because it kind of makes a claw shape with the arrows we're drawing. I don't know if you can see that. So maybe you've heard that before as well. But that is the way I organize. I just go through the first polynomial and go one term at a time, multiplying it with everything that is in the other polynomial. And it's possible that this method makes more sense to you and you're not sure about the box method. And if that's the case, then I don't want to discourage you from doing this. Feel free to do this if you prefer it over the box method, but I do think we should try the box method because I do think it is very useful. So I'm going to go ahead and do the same thing over here, combine like terms, and see if we get the same thing. Should be a 24. And yes, we do get the same thing. So that is your final answer for that. And then now we're going to talk about polynomial division. And we're just going to do polynomial division by a monomial. So notice we just have one term in the bottom of these fractions. So we're saying 3x squared plus 4x minus 6 divided by 3x. And the reason we're doing by a monomial is because it's pretty straightforward what we need to do. We really just need to separate this into 3 separate fractions, kind of like that. So I would just divide each of these terms individually. So 3x squared over 3x plus 4x over 3x, and then minus 6 over 3x. Now this only works if we have a monomial in the bottom. If I had something like 4x squared plus 2x minus 5 over a binomial over 2x plus 3, I cannot, the way this would separate is 4x squared over 2x plus 3 plus 2x over 2x plus 3, right? So it doesn't quite work the same way. We can't just separate things in the bottom like we can over here. So this is only a method we use when we are talking about dividing by a monomial. And the reason it works nicely with a monomial is because you can just simplify these individual fractions very easily. 3x squared over 3x would be just x, right? 3's cancel. The x's cancel. We're left with 1x on the top in the numerator. And then 4x over 3x, the x's simplify, and we're left with just plus 4 over 3. And then in this last one, 6 over 3 simplifies to just 2, so that's a negative 2 in the numerator, and then an x in the denominator. So this would be our final answer for that. We can go ahead and do the same thing for the next example. Separate it into 4 separate fractions. I'm going to go ahead and do that. So this is how you would separate it into 4 separate fractions, just each term in the numerator over 20. Make sure you keep the right operations, like this. Make sure you keep that negative. So here we have 5x cubed over 20. The x cubed is going to stay in the numerator. And then 5 over 20 is going to reduce to 1 over 4. So I'm going to keep a 4 in the denominator. This x squared over 20, nothing we can do there. Nothing we can simplify. Negative 4x over 20. So we're going to have a negative x in the numerator, and 4 over 20 simplifies to 1 over 5. So we're going to have a 5 in the denominator. And then plus 10 over 20, that simplifies to just 1/2. So that is your final answer for that one. All right, so that's the end of the notes portion. I do want to go over some of the things on Delta Math just to make sure you understand them, but make sure you have all of these problems written down along with some explanations before we get to that. So for the first section on Delta Math, I'm just asking you to find the missing box. So here it'd be 2 times 3x, so that would be 6x there. For the second section, you actually have to place the things onto the box method and then fill in your answers. Okay. For the next section, you actually have to create a box. So this, we would have 2 rows by 2 columns, and then you can fill it in like we would. And the next one, this is where things get tricky. So these are some extra large ones. So you would have to make sure you count properly. 4 by 2, because we have 4 terms over here, 2 terms over there. And then you can go ahead and start placing your terms like so. And then for the multiply binomials, we're taking away the box method, so feel free, and I encourage you to still use the box method on a piece of paper, or if you're more comfortable with doing FOIL or distribution, feel free to do that. But don't think just because the box method isn't here on the screen that I don't want you to do it. If that's what you're comfortable with, please do that on your scratch paper. And then finally, we have multiply polynomials. So here we have binomials times trinomials. Again, I definitely think you should use the box method on these. But if you're more comfortable with the distribution method, you can do that as well. If you have any questions, please come to office hours and have a good day.